Number 4. For question number 4, we have a differential equation question. And for part A, they want us to find the general solution. Whereas for part B, they want us to find the particular solution given some conditions. Let's start with part A straight away. In order for us to find a general solution, we must find the complementary function part and also the particular integral part. Let's begin, with finding our complementary function. Complementary function YC. How do we do this? We must first solve our homogeneous part. And what is that? Our right hand side equal to 0. So we will have d2y dx square minus 4 dy dx plus 4y equal to 0. From here, we will get our auxiliary equation, which is m square minus 4m plus 4. How do I get this? I just take the coefficient of each of this. Okay, now what we're going to do is we're going to use our calculator to find the value of m. Okay, polynomial degree 2, coefficient 1, negative 4, positive 4. Okay, notice that if you look at our calculator here, we have x equal to 2. It's not x1, it's not x2, it's just x. That means we have a repeated root. So m is equal to 2. If we work our way up to show our working, it will be m minus 2 equal to 0. And our factors is m minus 2 square equal to 0. This is the case of repeated root. Okay, and what is the formula for repeated root? Okay, our YC would be in this form. A plus bx e to the power of mx. And what is our m? Our m is equals to 2. Therefore, our YC is a plus bx e to the power of 2x. We're done with the first part, which is finding the complementary function. Let's move on to the second step. Our second step is to find our particular integral. Okay, if just now we're considering the left-hand side of our differential equation, now we have to consider our right-hand side, this part. Okay, what is our right-hand side? Okay, our right-hand side is equal to 2e to the power of 3x. That means our yp will be in this form, ce to the power of 3x. What we can do, okay, next step would be differentiating this. Differentiate this, d dx. And we will get dy dx. Okay. If you differentiate, okay, we will get ce3x. Because of chain rule, then we have to differentiate this. That is 3. Just put 3 at the front. We're done. Moving on. We have to differentiate another time in order to get our second differentiation. So it would be d2y dx squared. Okay. So we will get 3ce 3x. And then we're going to have to differentiate 3x and we'll get 3. So our second differentiation would be 9ce 3x. So what we will do next is substitute our y dy dx and d2y dx squared into our original equation. Okay. So we'll substitute all of this into this. We'll begin with d2y dx squared. So d2y dx squared minus 4 dy dx plus 4y is equal to 2e 3x. Why do we do this? We do this because we want to find the value of constant c. So from here we will get 9ce3x minus 4 multiplied by 3ce3x plus 4. What is our y? ce3x equal to 2e3x. Okay, we'll continue on this side. Let's just draw a line. Okay, now it would be 9ce3x minus 12ce3x plus 4ce3x equals to 2e3x. Now, let's take a look on our left hand side. Okay, we have 9c minus 12c plus 4c, which is equal to 1. So ce3x is equal to 2e3x. From here, we know that c is equals to 2. And we can conclude our yp to be, substitute back into here, 2e3x. Okay, so what is our general equation? Our general equation, or our general solution is y equal to yc plus yp. So a plus bx e2x plus 2e3x. We are done with part A. Okay. Let's just mark this so we know that we already got our answer. Moving on to part B. They want us to find the particular solution. So let me just copy back this one. A plus bx e2x plus 2e3x. How do we do this? Okay, we just have to substitute our y and x. So let y equals to 5 and x equal to 0. So if we substitute y and x, we will get 5 is equal to a plus b multiplied by 0. That will just be 0. E 2 to the power, okay, that will be 0 plus 2e to the power of 0. E to the power of 0 is just 1. So 5 is equals to a plus 2. A is equals to 3. Let's rewrite our equation. If we rewrite our equation, we will get y is equal to 3 plus bx e2x plus 2e3x. What's the next information that they give us? They give us the dy dx. So we have to differentiate this before we can substitute the value. But to make this easier, what we have to do is we have to expand this first. So let's expand. Okay, so y is equal to 3e2x plus bx e2x plus 2e3x. Okay, let's just move all of this to this side. Now, differentiate dy dx. If you differentiate this, you get 3e2x multiplied by 2. Why? Because we have to differentiate 2x. Chain rule. Plus, here notice that you have one x here, another x here. So we have to use product rule. How do we use product rule? We're going to differentiate that one first. bx, differentiate, we're going to get b. And then just copy our second part. So e2x plus. We'll do the opposite. Okay. We'll copy the first part. So bx. And then differentiate the second part. Differentiate the second part. We will get e2x multiplied by 2. Let's now, okay, differentiate our last term. We will get 2e3x multiplied by 3. Let's simplify our equation. You're gonna get 6e2x plus be2x plus 2bx e2x plus 6e3x. Next, what we're gonna do, we're gonna substitute our value. Let dy dx equals to, what is it? 12. And x equal to 0. Okay. So we know that it will be 12 equal to 6e to the power of 0 plus e plus b e to the power of 0 plus this one will just be 0 because you have x there. Okay. Plus 0 plus 6e to the power of 0. So 12 is equal to 6 plus b plus 6. Okay, so 12 equals to 12 plus b. Therefore, b is equal to 0. Notice that we already found our a and we already found our b. We can substitute into our general solution. Therefore, our particular solution would be we have two, we can opt to substitute into this one or the one that we already expand. Whichever you want. Both would be correct. Let me just take from the first part. So y equals to a. 3 plus or b 0. So I can just put plus 0. e2x plus 2e3x. So this will become y equal to 3e2x plus 2e3x. That's it. Let me just erase this, and mark my answer. Okay, that's it. With that, we are done finding both the general and particular solution for this differential equation.